Alright, back with exercise 4J here. This is looking at applying our understanding of linear equations and how we can use them to model real-life situations. So, finding a rule linking two variables, being able to sketch a graph or use the rule to predict a value, interpolation and extrapolation, fancy words there. Interpolation just means finding a value within the range of possibilities we've already got. Extrapolation, extending that rule outside the range of values we may already have. For these ones, we might not get into that though. Alright, let's have a look. The easiest way to look at these is just to do an example. I'll do the first one. I'll give you a chance to do the second one, but I might talk through my answer rather than just putting my answer there. So we'll see how we go. First one here. The deal offered by BikeShare, a bike rental company, has a fixed charge of $20 plus $5 per hour of use. Write a rule for the cost of renting a bike for T hours. Okay, well that first bit's not going to be too bad. The cost is always going to be $5. Oh no, $5 per hour plus the $20 fixed charge. So we could write it as, well, it's always going to cost you $20 and then it's going to cost you $5 for every hour after that. Can you see how that's analogous to y equals mx plus c? They've just written it in a slightly different order. We've got the variable in the second position, but there's no reason why you couldn't write that as 5t plus 20 just to get you more used to what you're used to seeing. That's an example of writing the cost in terms of the number of hours. Sketch the graph of that. Well, that won't be too difficult, will it? We're going to have 0 here up to 10. We have a y-intercept of 20. Going up by $5 increments there. There's my cost in dollars. Here's my time in hours. And they wanted us to go from 0 to 10. So we're able to do that here. At 0, it's going to cost me exactly $20. That's my y-intercept, isn't it? So it's going to start there. If I substitute in 10, I'm going to have 5 times 10 is 50, plus another 20 is 70. So that final value is going to be there at 1070, and you can just link them with a straight line. And then if you'd drawn this accurately on graph paper, you'd be able to read across and find the particular cost for any particular time. What is the total cost when a bike is rented for 4 hours? So I could go, well, 10, there's 5, there's 1, 2, 3, 4. Go up here, 4 hours, and then read across. And looking at my badly drawn diagram, it's estimating it to be $40. Well, let's see if that's actually right. So I could go over here and say the cost when time equals 4 hours. Now, that's a function notation that we haven't really done yet, but that just lets me indicate what value I'm evaluating the expression for. You could go cost time equals 4. That's the way we've tended to do it now. But either way, what's that going to be? It's going to be 5 times 4 plus 20. Well, that's going to be 20 plus 20 equals $40. Oh, so my diagram, even though it was hand-drawn, was actually accurate enough to give me a reasonable answer on that one. Cost is going to be $40 for 4 hours. If the total cost was $50, how many hours was a bike rented? So I could do this in reverse. I could read from $50 across and then read down. That looks like it's going to be 6 hours. Let's see how that would work if we actually did this using the equation. 50 equals, what do we have? 5 times t plus 20. Subtract the 20, I've got 30 equals 5t. Divide by 5, 6 equals t. So it would take 6 hours if the cost was $50. So we can read it from our graph, or we can just calculate it using the equation. 2 ways to do it. All right, there's one here for you to try. I want you to try it first. Salesperson earning $500 a week plus $10 for each item sold, and then I'll talk it through in a minute. Make sure you pause the video now. All right, so hopefully you've had enough time to try that. Let's see how we went. Write a rule for the weekly wage of the person if he makes X sales. So the wage And again, here I could write it as the wage in terms of X. X is my variable, the number of hours. This is function notation, just showing it to you so it won't be as scary when you get to see it in grade 11. There's no reason why we don't do it now. Plenty of countries around the world start introducing it from, a much younger age. So let's just do it now. Why not? What's this going to be? $10 for each item sold, and each item sold was an X, so $10 for each item plus the fixed cost of $500 per week, or fixed earnings of $500 per week. You can have 500 plus 10X, same thing. Both of those are fine. Draw a graph of W versus X between 0 and 100. Okay, well, this is probably going to be less accurate. 2, 4, 6, 8, 10, 12, 14, 16. Let's go up by $200 lots. You get the idea there. That's my wage, and it's a dollar value. And this is my X, which is the number of items sold. And we're going from between 0 and 100. 20, 40, 60, 80, 100. Don't think that's spaced quite as well as the previous one, but that's okay. When I put in 0 into the equation, 500 is the starting point. So that's going to be my y-intercept, 500 right there. And if I sell 100 items, that's going to be 1,000. So we're going to need to go up to because 10 times 100 is 1,000, plus 500 is 1,500. 1,400, 1,600. So 1,500 is going to be in there somewhere. And although you'd be doing this with a ruler in an exam, I would still write down the coordinates at that point. When X is 100, the cost is 1,500. Now that point is in the exact place, even if I've drawn it a little bit skew. How much does a salesperson make in a week if they make 25 sales? Well, you could try and read it off this. It looks like it's going to be around $600, but that's a wildly inaccurate graph. Let's use our equation. So the wage when I sell 25 items is 10 times 25 plus 500. That's going to be $750. Yeah, so you can see it was pretty inaccurate there. Part D, in a particular week, if they earn 850, how many sales did they make? So you put 850 where the wage is. It's 10 times X, we don't know how many they sold, plus 500. And it's just a matter of working backwards. It looks a little bit messy. Let's do that. Subtract the 500. We've got 350 equals 10x. Dividing by 10. 35 items were sold. And you could write that in a nice little sentence there. So it's nothing new in terms of the maths. Just a little bit of thought going into it. It actually helps us review all of our skills to do with these. Y-intercept, gradient, sketching lines, using substitution to evaluate particular things, rearranging formulae. Great questions for practicing a lot of the skills that we've been working on this year. Good luck with that. We will catch you next time. Bye for now.